Hey there YouTube, this is Ash with Crush Your Coding Interview. Today we're going to be talking about the HTML parsing problem. Essentially, we're going to be given an HTML string and we need to determine whether or not it's nested correctly. So in the first example on the right, we have a div element and then a paragraph element and then the text hello world followed by a closing paragraph element and a closing div element. Since the paragraph elements and the div elements match, we can say that it's nested correctly and we'll return the string valid. On the other hand, if we have an incorrectly nested string, like the second example on the right, where we have an opening div tag, an opening bold tag, the text hello again, but then a closing paragraph tag and a closing div tag, we want to return the first HTML element that would need to be changed for the nesting to be correct. In this case, we have a bold tag, which is we have an opening bold tag and a closing paragraph tag, which mismatch. If we were to change the opening bold tag to an opening paragraph tag, it would be nested correctly. So in this case, we'll return B. So we have a few simplifying assumptions so that we don't end up having to build a full-fledged HTML parser. First of all, we can assume that at most, only one HTML element will be nested incorrectly. So either it's going to be a valid HTML string or there will be one element that's incorrectly nested. Second, we can assume that the HTML elements will not have any attribute values, and this will make parsing the HTML string much simpler. Finally, we can assume that we'll only have these 5 HTML elements involved in any of the input strings that we receive. So let's take a look at a few examples. Our first example, we see that we have opening div, paragraph, and italics tags, then some text, and then closing tags which match the opening tags, so we would return valid. In our second HTML string, we see that the EM tag and the I tags mismatch. So we would return EM because if we were to change that to an I, it would fix the nesting. In our final HTML string, we see that our B tag mismatches with our div tag. And we'll return B because if we were to change it to a div, that would fix the nesting. So one interesting thing as we look at all of these examples is we start to see that this really is not an HTML parsing problem so much as it is a problem that's testing to see whether or not we understand how to use a stack. Now, before we jump into the code, let's take a quick look at exactly what a stack is and how we can use one. So a stack data structure is a last-in, first-out data structure. It can contain any serializable data type, and here we see two different stacks, one which contains the strings foo, bar, and do, and the other which contains the numbers 1, 0, and 42. So you can push items onto a stack. So here we see that we push foo, and then foo ends up being at the top of our stack, and then we push bar, and bar ends up being at the top of our stack. We can also pop items off of our stack in the reverse of the orders that we push them on. So when we pop our stack which has foo and bar, we receive bar because that's at the top of our stack, and if we issue another pop operation, we'll receive foo, and then our stack will be empty. So in the context of our current problem, what we can do is, as we parse through an HTML string, we can go ahead and push each of the HTML opening elements we encounter onto a stack. So in this case, we encountered the div opening element and then the paragraph opening element. So as we encounter each one, we can push it onto our stack, and then we know which opening elements we saw most recently. Then, each time we encounter a closing element, we can pop the last opening element off of the stack and verify that it matches the closing element we just encountered. So in this case, we would first pop off the opening paragraph tag, and then we would pop off the opening div tag, because that's the order in which they were pushed onto the stack. So once we have the stack data structure in place, detecting an incorrect nesting becomes pretty simple. So given this incorrectly nested HTML string, first we'll push the opening elements onto the stack. So we'll push our div, and then we'll push our paragraph tag. Then when we start to encounter closing elements, we'll start to pop items off of the stack. So we encounter the closing I element, and we pop the top element off the stack, which ends up being a paragraph tag, which we compare to our I tag, and we can quickly determine that that's our incorrect nesting. So we could return P, because if the P were changed to an I, now this would be correctly nested. All right, so let's dive into Visual Studio Code and see what this looks like in JavaScript. All right, jumping over to VS Code. Before I dive into the code, just a quick reminder, I've included a link down below in the video description to a GitHub repository containing all of the code I'm going to go over, so don't feel pressured to have to copy any of this down from the video. So first I have an HTML parser.js file which contains an HTML parser function that's currently empty that I'll use to implement my solution. Second, I have an HTML parser.test.js file that contains a suite of tests that will let us validate whether or not our solution's working. So we can go ahead and run the suite of tests right now by typing in npm test, and we'll see that most of the tests fail. There is one passing test, but that's just simply because we have a test that says we're parsing an undefined string, returns undefined, which is implicitly true for an empty JavaScript function. So let's go ahead and dive into this. First things first, let's make sure that that edge case continues to be handled correctly. So we'll say if not HTML string, then let's go ahead and return. So that's basically saying if we get an undefined input, let's go ahead and return undefined. Next, let's go ahead and define a stack. So we don't actually have a stack data type in JavaScript, so what we'll do is we'll go ahead and just use an array. Now the array type in JavaScript conveniently has push and pop operations which mimic a stack, so that'll work out pretty well. Additionally, let's go ahead and define a couple of variables which we'll use to aid us in parsing this HTML string. So first we'll define a current element, and then we'll also define a flag or boolean called closing element, which will initialize to false. Finally, let's get to parsing our HTML string. We'll want to return whenever we find an incorrectly nested element, so we'll go ahead and use a traditional for loop. So we'll say for let I equals 0, I is less than HTML string.length, I++. So this will allow us to iterate over our entire HTML string, and we'll go ahead and for convenience we'll say const char equals HTML string of I. So that gets us the current character that we're iterating over. Now there's 4 different possibilities that we can run into for this character. So it could be a less than, which indicates that this is the start of an HTML element. Or char could equal a /, which indicates that current HTML element is a closing element. Else, char could equal greater than, which indicates the end of an HTML element. Or char could be pretty much any other text string. So let's go through each of these cases and see what we want to do. So if it's an opening element, if it's a less than character, then we know that this is the start of a new HTML element, and we want to go ahead and reset our variables. So we'll go ahead and say current element equals an empty string, and closing element equals false, which is exactly what we initialized them to before the for loop. Next, if we run into a /, then we say, oh, the current element that we're parsing happens to be a closing element, so let's go ahead and set that flag to be true. Finally, if we get to a greater than symbol, then that means that we've gotten to the end of whatever HTML element we're currently parsing. And so this could either be an opening element or a closing element. So we'll say if not closing element. So first we'll deal with if it's an opening element, or it could be a closing element. So if it's an opening element, then we want to go ahead and just push it onto our stack. So we'll say stack.push current element. On the other hand, if it's a closing element, we want to pop the last opening element off of the stack. So we'll say const opening element equals stack.pop. And then we want to compare the current element with that opening element we just popped off the stack. If they don't match, then we know that we found our incorrect nesting, and we can go ahead and return that opening element since it's the first one we would have encountered. On the other hand, finally, we get to this last else, which is if we run into any other text. And so this means that either we're in the process of parsing an HTML element, or we're parsing some free-form text inside a paragraph tag or something like that. And in this case, all we want to do is concatenate the current character to our current element variable. So we'll say current element equals current element dot concat char. And that brings us to the end of our for loop. Now, if we've gotten to the end of our for loop and we have not returned any opening element, as we would have on line 31 if we've run into a mismatch of nesting, we can go ahead and return the string valid because we know that everything must be nested correctly if we've made it this far in our code. So now let's go ahead and jump back to our terminal, run our unit tests, and see how that turned out. So we run npm test, and all of our tests pass. So we're good to go. And that's all there is to it. It was just a simple stack problem masquerading as an HTML parsing problem all along. If you have any other questions or comments, or you have a suggestion for a cool problem like this that you'd like me to tackle in a future video, please go ahead and leave a comment below. So until next time, have a great day and good luck on your coding interviews.